Okay, can you?
So the next presentation, we have Biomedical Framework for Enhanced Experimentation from José, Rouillard, Jean-Marc, Vannobel, Marie-Helene, Bekaert from France.
Thank you. My name is José Rouillard. I'm with colleagues Jean-Marc, Vannobel, and Marie-Helene Bekaert. We are from the BCI team from Crystal Laboratory in Lille, University of Lille in north of France. And we are working on the Biomedical framework for enhanced experimentation. So the domain we are working on is health informatics and biomedical engineering application. And we know, thanks to the World Health Organization, that around 16% of the world population can be considered as disabled people. And of course, the purpose here is to design and implement multimodal solution adaptable to the patient, but also carers and health professional. The problem is that it's difficult, time-consuming, and expensive because of various problems, particularly from the users, cognitive or physical disabilities, for example. Problems of calibration and synchronization of the sensors, effectors for each session, from one day to another day, from 1 month to another month, for example. And they require to test various kind of inputs and outputs, for example, voice, gesture, etc., for each solution. And the question is how to provide multimodal and intelligent system for patients, but also with medical staff. For example, this expert here is looking at a different graph for electroencephalogram, etc., and he can see on the screen that there is a peak somewhere, and it's an intention of movement for the patient, for example. It's not easy for a machine to understand this. So how to reproduce the expert human decision made through several independent information channels aggregation is not so easy. The architecture of the framework is based on Firebase real-time database. We've got instant notification when modification occurs on the database. For example, here the inputs can be voice, touch, gesture, etc. on by a kind of devices, a smartphone, tablet, a laptop. We've got the multimodal engine here is working as fusion or fission system, aggregation of various inputs, for example. Other people can connect to family, etc., with other kind of device. And we've got what we call the famous Wizard of Oz. I say when the system don't understand really the command, when the Wizard of Oz injects commands when the machine are not able to do it themselves. I mean, complex or ambiguous multiple requests. When I say put that there, etc., for us it's easy to understand, but for a robot without the camera, it's not so easy. So a human can interpret and inject information in the system. One first case study is a traditional pick and place. So the context is very particular here. We've got only 1 degree of freedom with index finger. For example, with a patient like this man suffering from DMD, it's Duchenne muscular dystrophy. It's easy to understand that joysticks or traditional keyboard is not a good idea here. Maybe with the eye tracker is not interesting because the eyes are not very calibrate, etc. So we try to use a simple 1 degree of freedom system, and the task here is, for example, to try to move an object from one point to another one, and the system try to understand the way the user wants to do it. So it's a bimanual system. We've got 2 smartphones, and with the left hand, the user can choose a command, left, right, etc., and try to send the pick and place command with the lot of robots. And if it's okay with the right hand, you can inject the commands to the system really. As an output, there is a visual 3D view in Unity 3D application, also auditory with a text-to-speech senses, and tactical feedback provided by App Inventor in the Android phone. So, for example, where the target is here, this cube, the user wants to place this cube on the other target here, and he can choose to use the voice or to choose bilingual interfaces. And is it easy or not for this person to use this system? This question is here: how to provide the pick and place system. Here, technically, it's a Unity application connected to the Firebase database and piloted with the ROS, Robot Operating System. The protocol is called Move It. This is encapsulated in a Docker container, so you can use it on Linux, Windows, etc. I will see a video for a demonstration. Another case study here is on the same way. How can we use a kind of automatic home automation? Domotic, etc. So switch on or off some lamps, but not with Unity 3D or even robots applications. Visual program here. The task is to try to switch on or off various lamps. The instructions are given by the system randomly with no instruction. You have to switch on this lamp number 1, 2, 3, etc. And again, in inputs, the user can choose to use devices, but also an automatic speech recognition. For example, I would like to switch on the lamp number 3, number 1, etc. It's difficult at the beginning to know where is the 1. 1, 2, 3, 4, 5, it will be in the middle, for example. The next one. And as output, visual 3D again, auditory and tactical feedback provided by the Android's vibration. So here the technical part. What is interesting with this proposition is that you design in WebOps the lamps, etc., and automatically the system in Firebase declare for you the interactive object. This is a lamp. It is you can switch on or off, etc. You don't have to go in Firebase to declare lamp 1, lamp 2, etc. The system do it automatically. And I've got an example here. You can use also another kind of interaction when it's too difficult for a user to push the button. It's easy for us, healthy people, etc. But is it possible to use a lip motion here to interact thanks to a slight index movement and compensate the weakness of the finger pressure on the smartphone? So the idea is that the lip motion can detect the bones and the slight movement here injects the information in the system, just like if you really click on the button. Okay, for example, lamp number 5 here is in position off, and when I decide to make a little movement, maybe the system interpret it as I want to open to switch on or off. I will present this demonstration at the end. But in order to compare different solutions, the system is able to generate a random cycle of tasks to be performed by the patient. You propose, can you switch this on, etc. And he will you the time, the speed, the way the user interacts. You can choose to begin with a voice, for example, and in the middle of a session to change because of fatigue, etc., to another modality. It delivers automatically the prompts to diffuse to the connected device. So, as a conclusion, the Biomedical framework for enhanced experimentation, it helps in designing and testing various multimodal solutions for patients suffering from progressive disease, for example, DMDs, it's Duchenne muscular dystrophy, amyotrophic lateral sclerosis, etc. But it's interesting that one day you can, maybe the patient is okay to push a button, to use the voice, and day he cannot do this, so the system adapts itself to try to use another kind of inputs, for example. The tools used for interfacing are daily life objects, telephone, tablet, smartphone, etc., or inexpensive or free technology tools, software, live motion controller, app inventor to create Android smartphones interfaces, Firebase real-time database for the connection, and robots, for example, to use something else than the Unity free. It's open source and it's free to use. Test and usage evaluation are so facilitated by the framework, and we're shown that it's the first step to design and implement multimodal solution adaptable to patients, but also people around carriers and health professionals. And the next question is how to control real robots to enable the study of and comparison of different modality in terms of efficiency, usability, speed, etc. So with this scene here, we can understand in the future a user, a patient will be on the bed here and ask, can a robot appear a robot moving in the room, etc. If he asks orally, please bring me the bottle for us, it's easy to understand that he's talking about this bottle of water here, but it's not a connected object. So how the system will understand with camera or something, I don't know exactly, to move to this bottle, take it, bring it to the patient, etc. So to verify the usability of our tools with patient, we have to communicate with virtual and real robots like the Bekaert robot here. Something interesting also is to try to use electroencephalogram to detect intention of movement when muscles are not enough strong. For example, in this picture, it's easy for the system to detect on-off information with the joystick. It's okay, you can push it, but if you've not enough strength in your hand, muscle, etc., another solution is to try to detect the electrodes on the muscle itself, way. So you can detect the intention of movement even if the joystick is not moving. And in the very last possibility, it's interesting to see if the user had the intention to move. We can detect it on the electroencephalogram. For example, the electrode C3 and C4, they are called contralateral. It's the opposite of movement. The left is on the right of the part of the brain, etc. And maybe you can try not to touch the joysticks, keyboard, etc. And with the intention of movement, maybe you can use information connected to the Firebase to pilot a virtual or a real, maybe a real robot on the scene. Thank you very much for your attention, and if I've got a possibility to show the video, it's interesting to see all the static information here. You can try to send it. Thank you. Oh, it's maybe already in this icon here, I think, and maybe just play.
What was the one you sent? This one?
Yes, but yes.
Yeah.
So it's in French, but you understand that instructions are proposed by the framework architecture here with the touch inputs on smartphone using maybe sound okay. So it's a famous pick and place. The instructor asks, can move to this place. So the user try. Of course, it's a healthy people here, but we can project it with disabled people. So again, the user can change what they want. We've got the text-to-speech information. The user can do this only with the human interaction. Left, left, left. If it's okay, you can send the information. And now the move it protocol motion planning is calculated how to take the object and to move it at the right point. Okay, now it's finished. It's very simple at the beginning, but you can imagine the famous take this bottle. Okay. If you want to change and talk instead of touching the system, it will be fluid and we can use. Here the system is calculating the trajectory by the complete circle. The second example with the famous switch on and off lights. You can use touch, gesture with a smartphone, but also a laptop, again with a Firebase database. And here, the system asks the user to do something. For example, you can propose 3 tasks to do. Please switch on the lamp number 3. This is 3, and the user can new task. Please switch on the lamp number 4. So we got the auditory feedback, a vibration on the smartphone we're using. Now we will see the user begin the session with a touch and do not touch the system and use the lip motion in a few seconds. Here. Just with movement of index, the lip motion controller detects it, send it to the Firebase database, and the Wheelbot's application interprets. And you can return to the touch. You can choose to use the voice, something can be injected by the Wizard of Oz, etc. Thank you very much.
Thank you.